Hey everyone, when we think about building really powerful AI, our minds usually jump straight to these super complex algorithms, right? But that's only half the story. The real secret, the bedrock of any truly great AI, is great data. So today, we're going to pull back the curtain on this incredible process of turning total digital chaos into pure high-quality data, what we call the golden seed that lets AI really shine. All right, let's get into it.
So that brings us to the big question right off the bat. Why can't we just point an AI at the internet and say, learn? Why do we need to go through all this trouble to create a special golden seed dataset? Well, the answer is actually pretty simple, but it's absolutely fundamental. It's because most of the data you find out there in the wild is, frankly, a total mess. It's inconsistent, it's unlabeled, it's full of errors. Trying to train an AI on that, it'd be like trying to bake a world-class cake using flour that's mixed with sand and pebbles. The final product just isn't going to work, no matter how good your oven is. To build reliable AI, you've got to purify your ingredients first.
So let's start at the very beginning with the source of the problem. Our starting point isn't some nice, clean, organized library. Oh no, it's more like a gigantic, overflowing digital junkyard. We call this the raw data set.
So let's imagine you want to train an AI to recognize different animals. You might just scrape, say, 100,000 images off the internet. That's your raw dataset. It's massive, which sounds great, but it's also jam-packed with blurry photos, pictures of dogs tagged as cats, and maybe even a picture of a car that somehow got in there. This is our unrefined, messy pile of flour.
And this chart just lays it all out, doesn't it? It shows the core trade-off we're facing. We start with 100% of the data we could find, a huge volume, but the quality is way down there, maybe 20% if we're lucky. Trying to train an AI on this would be a disaster. It would learn all the wrong things from all that noise. This is our starting line, and from here on out, we have to start giving up quantity to get quality.
Okay, so that brings us to our first step in the cleanup process. You can think of this as our first big sift. We're going to use some clever automated methods to find a little consensus in this giant mess of data.
This step creates something called the core dataset. What we do is we run different algorithms that are designed to group similar data together. That's a process called clustering. And the trick is, we don't just use one algorithm, we use several. We only keep the data that all of them agree on. It's just like passing our messy flour through a bunch of different sieves to make sure only the finest particles get through.
So for example, we might use an algorithm like k-means and another one like GMM. Now they both group data, but they do it in slightly different ways. By only keeping the images that both of these algorithms confidently put in the same pile, let's say the cat pile, we start to automatically filter out a ton of the obvious junk and the really ambiguous pictures.
And boom, look at the result. It's a huge change. Our quantity is dropped by more than half, down to about 40% of what we started with. But look at the quality. It has skyrocketed up to 80%. We've tossed out a lot of data, for sure, but what's left is so much more trustworthy. It's a massive first step.
Okay, so our data is cleaner, it's more organized, but we're not done yet. Now it's time for the next level of validation. We're going to see how well AI models themselves can handle it. This is my favorite part. I call it the AI bake-off.
What comes out of this stage is the core of core dataset. We take our already refined data and we use it to train several different AI models. Then we test them. We only keep the data points that every single one of these models can recognize with super high confidence. We're talking over 90% accuracy. So our analogy is back. We're basically test baking our flour in a bunch of different ovens. We only keep the batch that makes a perfect loaf in every single one. So we might grab a model like EfficientNet and pit it against something different, like a vision transformer. They have totally different ways of seeing the world. The idea is, if a picture of a cat is so clear, so perfectly cat-like, that both of these AIs can look at it and say, yep, that's a cat, with over 90% certainty, well, then we can be pretty confident it's a top-tier example for training.
Let's check the scoreboard again. The trend continues. Our quantity is now down to just 20% of where we started. Tiny, right? But the quality? Another huge jump, all the way to 95%. We are getting so close to perfect data. Data that isn't just clean, but is certifiably robust from an AI's point of view. And that brings us to the final stage of our quest. This is the last hurdle, and it might just be the most important one. We've used machines to check the work of other machines. Now, we need the ultimate seal of approval, an agreement between the AI and a real live human expert.
This is where we finally mint our golden dataset. This stuff is the absolute cream of the crop. It is made up of only the data points where our super confident AI predictions match perfectly with what a human expert says. This isn't just a good recipe anymore. This is the certified 5-star golden recipe, ready for the world's best chefs.
This last check is what really locks in the quality. We have an actual animal expert go through and label the images, and we compare those labels to the results from our AI bake-off. And where they overlap, where the human and the machine are in total agreement, that's our gold. This step is so critical because it makes sure our data isn't just statistically sound, but that it's also correct in that nuanced, contextual, real-world way that, for now, only a human can truly provide.
And here it is, the final result. Look at that. We are left with a tiny fraction of our original data, just 8%, but its quality has soared to 99.9%. We have successfully traded a mountain of digital junk for a small but incredibly precious handful of digital gold.
So let's just quickly recap that whole journey. We started with the raw dataset, our big pile of messy flour. Then we used clustering to create the core dataset. That was our first sift. After that, the AI bake-off gave us the core of core dataset, our test baking phase. And finally, the human-AI agreement gave us our prize, the golden dataset, the perfect, validated golden recipe.
Okay, so we've done all of this hard work. We've gone on this epic quest and mined this digital gold. The big question is, now what? How do we actually use this to build a smarter AI?
Well, you don't just dump it all in at once. You use what's called a quality-first approach. You start by training your AI only on that small, perfect golden dataset. This builds an incredibly strong, accurate foundation. Then, to help it learn to handle a wider variety of situations, you can start to supplement its learning with the slightly bigger core of core set, and then augment with the even bigger core set, all while keeping a close eye on its performance.
But here's the coolest part. This whole thing isn't a one-and-done job. It's a living, breathing, recursive framework. Once your AI is trained, this system creates a feedback loop. You can use it to get even more specific, like taking your rock-solid cat category and running this whole process again just on those images to identify breeds like Persian cat or Siamese cat. It's a system for continuous, never-ending improvement.
And this is why all of this matters so much. When you're talking about AI that makes life or death decisions, diagnosing a disease, driving a car, managing a power grid, you just can't afford to build it on a shaky foundation of messy data. In these fields, this obsessive quest for data quality isn't some luxury. It is an absolute necessity for safety, for reliability, for trust.
So I'll leave you with this thought. Remember that final step where we compare the AI's conclusions to the human experts? Well, what happens when they disagree? In our process, we just discard that data point. But it brings up a much deeper question for the future, doesn't it? When the machine and the human expert don't see eye to eye, who should have the final say? The AI, built on pure statistical certainty, or the human expert with all their years of nuanced real-world experience? Something to think about. Thanks for joining me.